In today's note, we're going to be looking at multiplying powers with the same base. So a power is defined as an expression that has a base number and an exponent. So we can see an example over here to the right, and basically we're just going to break that down. So the entire thing of 2 to the power of 4, or 2 with the exponent 4, that whole thing right here, that's the entire power. The base is 2, and the exponent, or the smaller number that's raised up, is 4. And basically what the power tells us in shorthand is that we are to multiply the base, which in this case is 2, by itself the number of times that's indicated by the exponent. So basically what we see here of 2 to the power of 4, or 2 to the exponent 4, is just the short way of writing 2 times 2 times 2 times 2. And just a thing to note, the dots in this just represent multiplication. Right? So whether you have to highlight that or just make a small note, it's just another way of writing or representing multiplication. Right? As we get into our further units, we're going to start introducing variables or letters, and sometimes the letters, usually X, can look like multiplying, so that's why we tend to use either dots or brackets to represent multiplying. Which is why we could also write 2 to the power of 4 as 2 in brackets, 2 bracket 2 bracket 2 bracket 2. So again, it's all representing the same thing. And basically, as long as we're showing that we're multiplying 4 2's together as the exponent tells us to do, then that's good. And we can see multiple representations of it. A power can also contain a variable as its base. So for example, x to the power of 7. So here we still have, so this is our base. Actually, let me do it a similar way. So the entire thing here is our power. The x is our base, and the 7 is our exponent. And again, this is the short way of saying the base times itself 7 times, or x times itself 7 times, which is x times x times x times x times x times x times x. Even though we can't come to a final answer, we can still write this in as a power or in expanded form. And expanded form is basically this entire thing. Basically, expanded form is just expanding it. So, for example, if we look at the next one, we're dealing with the variable y, but we want to write the following expression using a single power. So what we see here is we have y times y times y times y times y. So the variable in this case, or the thing that's being multiplied multiple times, is going to be our base. So in this case, y is going to be our base. Our exponent is going to be the number of times it's multiplied by itself. So if I go back and look, I see 1, 2, so 1, 2, 3, 4, 5. So I see y 5 times, which means my exponent must be 5. So that's just a brief overview of of powers. And what we're going to do next is look at the law of multiplying powers with the same base. So what we want to do is complete the table complete the table below and include an example on our own. So the first one's done for us. Basically, what we're doing is in the expression I have x to the power of 3. So that means I need to see x 3 times. Then I have x to the power of 4. So I'm going to put that in there. So that's x 4 times. And because it's multiplying, I can just put them one after another. And now if I want to simplify this, my base is going to be x, and my exponent in this case, is how many x's I have, which is 7. For the next example, m to the power of 4, same idea. We're going to write out 4 m's, and then m to the power of 1. Remember, if we don't see anything, we assume it's 1, so I can just put that m there. And if I want to simplify this, my base is going to be m, and then how many times is it shown or multiplied? It is there 5 times. 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 3. So that means I'm going to have 2 and 2 for the first one. The next one is going to be the same thing, so 2 2's. And then finally 3 2's. If I want to simplify this entire expression, I know my base is going to be 2, and I just have to count how many times the 2 is represented. So 1, 2, 3, 4, 5, 6, 7. So it's going to be 2 to the power of 7. And then finally, k to the power of 2, so 2 k's, and then k to the power of 5. 1, 2, so 1, 2, 3, 4, and there's our 5th one. And if I want to express this as a single power, well, k is going to be my base, and the exponent in this case is going to be 7 because there are 7 k's. So here we've multiplied powers with the same base together, we've expanded them, and then we've rewritten them as a single power. Now, if we want to do this over and over again, we can write out the expanded form when we're multiplying them, and then simplify it. But the question is there a shorter way to write the expression out without having to go to expanded form? Is there a way I can go from this expression right to a single power? So if you're not sure, take a look at the final result, the single power, take a look at the expressions, and see where can we go, or what can we do to jump from the expression to the single power. And what you should see, or what you should notice, I'll go back and highlight some of this. If I look at the exponents in my expression and the exponent in my simplified single power, we should start to see a pattern. And that pattern is all your exponents in your expression on the same base added up equals the final exponent in your single power. So there is a shorter way to do this, and it's just we have to add the exponents. So basically, as a summary of what we just did, when we multiply powers with the same base, we can apply what's called the product rule. And the product rule, or the rule for when we're multiplying powers with the same base, I'm sure I'm going to highlight that and put a star next to it, because they have to have the same base for this rule to work. And this product rule states that when 2 or more powers with the same base, I'm going to highlight that again just to drive that home, are multiplied together, the exponents can be added to simplify the expression. So we see a couple examples here. Q to the power of 7 times q to the power of 5. They have the same base. I can add 7 plus 5 together, so I get q to the power of 12. In another example, h to the power of 3 times h to the power of 4 times 10 to the power of h times h, all the same base, so I can add my exponents up. 3 plus 4 plus 10, and then plus 1. If you didn't know, when we don't see an exponent, we assume there's an invisible 1. And then when we add all those exponents up, we get 18. So h to the power of 18. This little note is just saying that technically the exponent on the last h is 1, and since there is just one of them, we don't have to write it. If you feel comfortable doing that, you can write that in. You don't have to. It's assumed that if there is no exponent, it is 1. So just as some practice, try to go through and simplify the following expressions below using the power rule. So I'm just going to take a second to pause. Feel free to pause the video and then go through and try the expressions. Alright, so hopefully you paused and you didn't just wait. But if not, that's fine, because you can go through and just practice again on your own. You can find more practice questions. But to simplify the expression, we're going to do m3 plus 19. So because the bases are the same, we can add the exponents. So we get m to the power of 22. For the next one, r, so it's all r's multiplied together. R to the power of 4 times r to the power of 11 times r to the power of 9 times r. So I can add all of those exponents. 4 plus 11 plus 9 plus 1. And when I simplify that, I get r equals, or r to the power of 25. So if you were to expand that, you would see 25 r's all multiplied by each other. And the next one, y to the power of 2 times y to the power of 45. So this is one example where it would be very impractical to expand it, because you would have 45 y's written out. But because it's the same base, I can add my exponents together. So 2 plus 45 is 47. So I get y to the power of 47. For the next one, a to the power of 6 times a to the power of 8. So I'm going to add my exponents, 6 plus 8. So I get a to the power of 14. And then finally, I have a bunch of m's all multiplied with powers. So I can add them. So 4 plus 2 plus 7 plus 10 plus 2 plus 2. And when I simplify it, so 4 plus 2 is 6, plus 13, 23, 25, 27. So m to the power of 27 is my final one. So the key thing from this note is, again, just refreshing yourself on what exponents and powers are and how they work, and then understanding that if I am multiplying powers with the same base, there's a quick shorthand way that I can do that so that I don't have to go through and expand them. And that short way is the product rule, where I multiply, or if I'm multiplying powers with the same base, I just add the exponents to get my simplified power. But just keep in mind, it's the same base. It has to have the same base for the rule to work.